Today I'm going to be showing you how you can create this really cool procedural ugly sweater setup in Blender geometry nodes that'll basically let you turn any mesh into some really nice knitted pixel art. So this whole setup is basically just a curve that's been instanced a bunch of times with some voxel conversion and then raycast detection, which helps us map colors to certain instances of the curve to a shader. So as far as I know, this setup only really works in Blender 5.0 and beyond. The modifier-based geometry nodes have been around a little bit longer, but there's just some issues with the voxel conversion which is needed for creating the patterns in certain older versions. So I'm going to start up a new file here, and we're going to use the default cube to put our geometry nodes modifier on. So we're going to put a new geometry nodes here and call it sweater or something like that. We're going to pull out here and open up our geometry node tree. And we don't really need the cube input, so we can get rid of that and add a curve line. And we're just going to want to move it, this endpoint to 1 meter on the x-axis, just so we can view it by pressing 1 on numpad. We're going to add in a resample curve node here and set it to length, just so when we instance it, it doesn't change depending on the count. And we're just going to set this to 0.025. So the basic principle behind the actual overall knitted look is basically just using a set position node, which acts as a displacement for the geometry, and then controlling that with a bunch of trig functions. Now, while we're at this first step, I just want to point out that we're going to be working basically in 1x1 blocks. So each instance should hopefully take up 1 meter by 1 meter in the grid. And that way, when we get to the part where we make it turn into pixel art and stuff, it'll be a lot easier to control where the voxels need to go. So with this set position node added, we want to add a combine XYZ so we can individually control each vector, and we're just going to plug that into the offset here. We also want a position node so we can read the position of each point on the curve, and we'll start by displacing the z-axis. So we want to control it with a cosine function, and as you can see, we've already got a bit of a curve here, but we basically want to shorten the period of the curve so it only takes up 1 meter. So to do that, we're going to multiply using the vector multiply node, plug in pi times 2 for the period there, and as you can see, we're already getting the full period of cosine there. And since we kind of want to be working on our grid axes, we're going to add another multiply node at the end, but this time setting the values to -1.5 on the x-axis to flip it around, and -1 on the y-axis. So that places the middle of the curve perfectly on the x-axis, which should be a little easier for us to keep track of. We're using the same kind of idea for all these other axes, so next we'll go to the x-axis. So first we plug in the position. For this one, we actually want to change it to a sine function. Plugging that in, we get a bit of a weird shape, so we actually want 4 times pi, so we're just going to multiply this by 2. We'll reset this multiply at the end so we can control it, and that's more like the shape we want, but I'm just going to bring this down to around 0.55, so we get that kind of shape we want. And finally, we want to displace on the y-axis. We want to duplicate this cosine function that we used for the z-axis. Plug that in, but we actually want to make this 4 times pi as well, so multiply that by 2. You can see we get that nice curve. I'm going to set this a lot lower to around 0.3 and -0.95. So now that we've got the curve done, we basically just need to array this as many times as we want. So after the set position, we can now add array nodes. I'm going to set this to offset. We'll turn off realize instances just for performance. Maybe set this to something like 20. And then we want to vertically array it, so duplicate that. Change the axis to the z-axis, but we're actually going to set this to 0.5, so they kind of interlock like that. But as you can see, they're still aligning to the grid. So this one is still exactly 1 meter. This one's still 1 meter. All the instances are still 1 meter. Now we can give it the real shape, so we can add a curve to mesh node. And then for the profile curve, we want to add a curve circle. So that sweeps around each of our curves. I'm going to set the resolution to 8 just for performance as well. And the radius around 0.2 meters. So we get that nice thick wool effect. And that's looking really good. And of course we can add a quick little material to that by doing a set material. And that's looking really nice by itself. You can use a set position node to give it a bit of a wave, for example, with a noise texture. But now I'll show you how to set it up so you can have little patterns on it by converting meshes to pixel art on the actual surface. So to start, we're just going to turn on realize instances on both these nodes just because we need to be able to individually control each instance. And we want to create a collection up here, a new collection which is going to have all our objects that we turn into patterns on the sweater. Call it something like patterns. And you just want to add some sort of mesh into there. I'm going to add a Suzanne, although I think it might look a bit strange. Just set it up so it intersects the mesh, and I'll just disable the collection for now and make sure I've selected the main collection. So we can drag this collection into our node tree and it'll give us this collection info node. We want to set this to relative so all the transformations are applied. And we want another realize instances node. I'm just going to make it so we're viewing the meshes that we're editing. And we want to give it an effect that kind of looks like the block remesh modifier that you can get usually, this kind of effect. So to do that, we're going to use a technique that's used in programs like Houdini a lot, where we turn the mesh into a volume, and then we turn that volume back into a mesh, and that way we can actually control the individual voxels and kind of set a size that we want for each of them. So I'm going to add a value just because we need to control multiple things with the same number. We're going to set it to 0.5 and change both of these to size. And that way we can control the voxel size. With this, we want to add another set position node, and we can use this position node from down here and get that to a vector add, which we're going to set all the values to 2 on. And then we want a vector snap node, which we're going to plug into the position of our set node. And we want the snap value to all be 0.5, so we're going to plug that one in there. And look at that, we get our nice Minecrafty Suzanne. As you can see, we're actually displacing the geometry a bit in this whole process. As you can see, that's quite a bit off. So we're going to add a little transform node after our voxel setup, and just set all these to -1.75. That should put it basically back in the same spot. Yeah, that's pretty even. And now we're going to do all our ray casting, so basically detecting what instances of this array we've done are closest to each voxel in the group. So we want to get a raycast node, have the target geometry plugged in there like that. This ray direction setup is actually correct, but since we need to control multiple things with that same value, we're going to add a vector node and have the same inputs there. So -1 on the z-axis. Then our hit normal output is going to go to a dot product, and this same output is going to go into the bottom vector there. And after that, we just want to compare it with a greater than node and just leave it at greater than 0. So we're going to have to capture all this data and then send it to a separate material. So after our arrays, we're going to add a capture attribute node here. And set it to splines, since each of these are an individual spline object. And then we're going to add the result into here. I'm going to create another material. So we'll duplicate this set material and add a new one here. Call it multicolor or whatever you want to call it. Set this to that. And then plug this result into here. And look at that, it's passed that through and we've got that nice pixel art effect now. So you might be happy with that. That's a pretty cool effect. As you can see, we can even move this around and animate it and it will still work. But if we want to pass different colors into this, it would be kind of inefficient to duplicate different materials and have a whole bunch. So instead, there's this cool little trick you can do with color attributes. So if we go back to our Suzanne here, and you can do this with as many different objects in your group as you want. So I'm going to add an extra sphere to show you, drag it into the collection, and on the Suzanne we're going to go to the data tab and go to color attributes, add a new one, call it color or coal or whatever, and set it to whatever color you want it to be. So maybe we want it to be a nice green, and then we want this one to be blue. Make sure it has the same name as well. And then back in our geometry nodes, we want to add a nearest surface node here and plug the output of this realize instances of our collection into the mesh. We also want to change this to color, and we will also want to get our attribute through a named attribute node. We find right here it's color, and we pass that into the value of this sample nearest surface. Then we pass the value over to our capture attribute. Now it adds a new entry and a new output. And we can pass this through to the geometry output. Now back in our shader for multicolor, we should be able to get a color attribute node, and we should find our output here, which has a long crazy name. But if we plug it in there, as you can see, it gives each pattern their specific color. So it's pretty cool. So that's how you create this cool procedural ugly sweater setup in Blender. If you have any improvements or suggestions for it, leave them down in the comments, and I hope this video helped you out.